In number 10, we have 4 graphs, and we want to know which do not intersect the third quadrant. So let me write down all the graphs first. So we have letter I is 2 cosine theta. Number 2 is 1 plus cosine theta. These are all R equals. Number 3 is, let me write this as R equals because this one is not going to be. We have 2 cosine theta, 1 plus cosine theta. The third one is R squared equals -4 sine 2 theta. And the last one is R equals 1 plus 2 cosine theta. So we have these 4 graphs and we want to know which of them do not intersect the third quadrant. So we're going to have to know what all of these look like to a degree. So for the first one, R equals 2 cosine theta. So remember that if you just have R equals and you have sine or cosine of theta with some constant, you're just going to get a circle, but it's going to touch the origin and an edge instead of the origin being a center. Since this is cosine theta and we had a positive number, the circle is going to exist on the right half of the graph only, and it's going to have a radius of half of this constant, which is 1. So it's going to look like this, where the origin is the leftmost point, the point 2, 0 in Cartesian is the rightmost point. This graph does not intersect the third quadrant, which would be down here, at all. So that is one of our correct answers. So 1 does not intersect the third quadrant. Number 2, so we have R equals 1 plus cosine theta. Okay, this is a cardioid because we have our A plus or minus B cosine theta standard form. So there's a couple things we know. It's cosine theta, so it's a horizontally oriented cardioid. The sign on cosine is positive, so that tells us that the big side of the cardioid is to the right. And the numbers, the coefficients, or the A and B, let's say, in that formula, are equal. So that tells us that we have a cusp, not a loop, and the cusp occurs right at the origin. So we have a point at the origin. And how far does the big side of the cardioid go? And remember, we know it's to the right because it's cosine and positive. It goes, the sum of those two numbers, 1 and 1, gives you 2. So this graph is going to look like this, approximately. And again, that's just going through the standard formula for a cardioid. So does this graph intersect the third quadrant? Yes, it does. It has this little part in the third quadrant down there, so this one is no good. All right, number 3. Let me get this a little closer so I'll have room for the last one. Okay, so number 3, we have R squared equals -4 sine 2 theta. So recall that the R squared equals constant times sine of 2 theta, or cosine 2 theta for that matter, is another standard form that you should recognize, and that's the Loomis zones. So remember that for sine, you have a graph that has diagonal loops normally. For cosine, you have the infinity symbol graph, the horizontal loops. So the difference here is that we have a negative sign in front, and that is something that you probably haven't seen before. So what does that do? Well, keep in mind, say this negative sign wasn't here. There are plenty of values of theta that don't work because sine of 2 theta would result in a negative number, and since we have R squared equals, we couldn't have that, and that's why the standard graph of this only has 2 leaves instead of your normal 4 leaves for sine of 2 theta, because these over here would have resulted in a negative value, and you can't have R squared equals a negative value. But if we throw the negative sign in front, then those values are the ones that would give us a positive value, and those are the correct ones. So your normal sine 2 theta graph looks something like that. R squared equals constant sine 2 theta. It looks like that. So we don't have that for this one. We have the negative, which means all the points where we didn't have a value because we couldn't have an imaginary number, now we have those and not the opposite. So this graph is going to look like the same thing, except it's going to be in the opposite two quadrants. Does this intersect the third quadrant anywhere? No, it only goes through the origin and exists in the second and fourth quadrants. So this one is good. Okay, and finally number 4. So we have 1 plus 2 cosine theta, so again we have a cardioid. And let's go through the rundown similar to the one above. We have its cosine. The sign on the cosine is positive. Again, that tells us horizontally oriented cardioid. The big part is to the right. In this case, the coefficient on the cosine is bigger than the constant out front. So that tells us that we're going to have a loop. How big is the loop? That's the difference between these two numbers, which is 1. And how big is the big side of the cardioid? That's the sum between those two numbers. That's 3. So 3 is where we start. Or 3 is the big side of the cardioid. And we're going to have to come in and it's going to have a loop. And the loop is going to be of size 1. So it's going to look something like that if that was more symmetric. And that's going to be at 1 there. So pretty similar to the one above, except now that the coefficient on the cosine is bigger, that creates a loop. And remember, the loop size is always the difference between those two numbers. So does this graph intersect the third quadrant? Definitely, it's got this little part here. So this one doesn't work. So we only had numbers 1 and 3 that did not intersect the third quadrant.